Hey guys, welcome to week two. Are we week two? End of week two. Um, Sorry I didn't get this out a little earlier. We're going to talk about the master partition table as it relates to legacy drives less than 2 terabytes. The master boot record schema for partitioning is still pretty widely used because there are still a lot of drives under 2 terabytes. I think we're going to see the master boot record and the master partition table schema go away in the relatively near future because we will see more GPT schema become more ubiquitous as 2 terabyte drives or larger become more common. And we're getting there quickly. So this may be, in a few years, we probably won't be teaching master boot record and master partition table schemas as much. The focus is still on that. Well, you should know both, master partition tables, MPT, and GUID partition tables, right? GPT. So both of those are important schemas to understand, but we're going to focus here today on the master boot record, specifically the master partition table. All right. So let's see. Uh, I'm going to show you a slide and then I'll show you some real life on the background on the desktop here. So what we're looking at up here is just kind of a snapshot of my master partition table on my OS drive, right? And what I have highlighted up there is the first entry in the master partition table, and I'll show you more about that again in a second. But the idea is we've got these 16 bytes that are highlighted there. They represent the first partition of my disk, or at least the first partition that the hard drive recognizes as the bootable partition. Okay, and then after that there's another 16 byte strand, and then another 16 byte strand, and then there's 16 bytes of all zeros because I only have 3 partitions on this drive. And again, I'll show you what that means in a minute. But this table that we see up here, this is a byte level analysis of the 16 bytes for each entry of the master partition table. So if you look up here, the first offset 0, that's right here, the 80, hex 80 is the first byte in that entry. And what we have is it's just 1 byte long, and it indicates that it's either a bootable partition or a non-bootable partition. The 80 tells us that it's bootable. I forget what hex 80 is actually 8 times 16, which is, what's 8 times 16? 128. I should have known that off the top of my head. 128. And as I recall, there's some significance to that why they decided to make 128 equal to bootable partition and 0 non-bootable. I don't. It's something. I'm embarrassed. I don't remember why. But anyway, that is the first thing you want to look for. Where's the operating system, right? Where's the bootable partition? Could you have more than one bootable partitions? You could, but the master partition table's probably only going to tell you one of them, or the primary bootable partition. Okay. The next 3 bytes, if you look at the chart up here, the next 3 bytes are the starting address of the partition in CHS. So again, really legacy. Remember we did the lab converting CHS to LBA, and I'll walk through this a little bit now. Here's a real world scenario, but it's kind of redundant because as you'll see in a second, we've got an LBA address in the master partition table as well. Why the redundancy? I'm not sure, to be honest with you. The next partition, or the next byte in the entry, byte number 04, so it's the 5th byte, is the partition type. It's just 1 byte long. There's a code that tells us what partition type it is. And then the next 3 bytes are the ending CHS value. So the last sector of the partition in CHS. And then, again, redundant. And then we're going to get the next 4 bytes starting at hex 08, offset 08, which is actually the 9th byte in, that's where we get the starting LBA or logical block address. And it's in little endian. If you don't know what that means, we'll cover that. And then the last 4 bytes of that entry are the total sectors of the partition. So it doesn't give us the last sector, it gives us the first sector and the total number of sectors, so we can figure out what the last sector is, right? So anyway, that's kind of an overview of a partition entry in the master partition table. Let's see what am I really talking about in case this is not abundantly clear. Here is the entire master partition table formatted, right? Right here, I mean formatted, highlighted, right? So and it's got 4 16-byte entries. So here's the first 16-byte entry. That's the first partition, represents the first partition. Here is the second partition entry. Here's the third partition entry. And here's the fourth partition entry. And then the 55AA is the signature of the master boot record. So what we're really looking at are these 64 bytes on the master partition table. And now we're going to get into looking at the first entry, right here, those 16 bytes. Let's go in and now analyze those a little bit based on the chart that we just did. All right, so back to our slideshow here. Okay, so just really quickly, we don't want to spend too much time on this, but we've got the next 3 bytes after the boot primary boot partition flag right there, the 80. The next 3 bytes tell us the starting head sector cylinder. Now you're like, wait a minute, I thought it was CHS, cylinder head sector. Well, yes, but then of course, for whatever reason, Microsoft decides to, put it in this order on the drive. So the 202100 actually represent the head 20, that's hex, not 20, right? Starting sector 21 and starting cylinder 0. So what does that mean? How do we actually go in and look at that? Well, let's look at it first really quick on the what we're actually talking about are these 3 bytes as highlighted previously. And so you can see that we're going to take these apart. Now, remember, this is hex 20. It's not 20. What's the value of hex 20? Well, you could do it in your head and say that the second column over is the 16s column, so 2 times 16 is 32. So that is the 32nd what? The 32nd head. Okay, so if we're on the first cylinder, if we imagine, again, what's kind of silly about this is that my physical drive 0, if we go to the properties pane, you can see it's a solid state drive. It's a Samsung SSD 950 Pro, and so you can see that this drive has no platters in it. It has no cylinders or heads or sectors. So again, it's kind of silly that they even still do this addressing, and they must have the reason for it. I don't know what it is. It doesn't make sense to me, but makes sense to somebody, or they'd probably stop doing it. I don't know. And so you can see here again. Here's the CHS schema for this disk. Even though it has no platters in it, it has no physical hard disk drive, right? It's all solid state. They say, okay, well, logically, we've got 31,130 tracks per platter, even though there's no platter, right? So that gives us 31,130 cylinders. And if you're visualizing this, you can imagine from our previous lecture, how many tracks are there per cylinder? Well, that depends on how many heads there are on the drive, right? How many different. So, I mean, this is kind of silly. 255 tracks per cylinder. So if you imagine the cylinder as a stack of platters, how many tracks? Well, that's top and bottom of each platter. So if there's 255, that's odd, first of all, because it should be an even number, right? I mean, even if, I guess we're assuming it starts with head 0, but that it should still say there's 256 tracks, right, or 256 heads. But that would mean divide that by 2. If there's 2 heads per platter, right, that would be 128 platters. Be 128 platters in my hard drive. It's obviously it's not. It's a solid state drive. But and then there's 63 sectors per track. So that's all right over here. That's in the FTK goes out and figures that out for us. It is probably I forget where it is notated. It's probably in the boot. It's probably included up here in the MBR boot code. It probably tells the you know, it's probably telling the operating system and file system how many what the CHS schema is. Anyway, so but okay, now we know that, okay, and we know that we've got head 20 or head 32. If you didn't want to do the math in your head, you could use Windows FTK hex value interpreter, right? And it would tell you that hex 20 is decimal 32. So we know that we have 32 heads, or from that first cylinder, cylinder 0, 32 top and bottom of imaginary platters going down. All right, let me see if I can, sorry about the external noise. It's Saturday morning, my kids are doing their chores. All right, let's see. So back to the PowerPoint, what are we talking about here? We're talking about the starting head, starting sector, and starting cylinder, okay? So let's take a look at that. Here's a screenshot of what you just looked at in FTK Imager. If we take our starting address, our starting head of 20, which is actually 32, right? 2 times 16, and our starting or our leftover sectors for the next head are 21 sectors. No, not 21 sectors. Hex 21, which is 33. Okay, so we're going to take our head times 63 sectors per head or sectors per track, right? And that gives us 216 sectors, right? So we're going to multiply the 32 or hex 20 times 63 because that's the number of sectors per track, and that gives us 216 sectors. Remember, we're converting our CHS over to LBA. And then I'm going to add 33 additional leftover sectors from the next head. Okay, and that'll give us our starting LBA for this partition, which if you add those together, 216 plus 33 is 249. But don't forget, we have to subtract 1 because LBA starts at 0. It doesn't start at 1. So 0 to 248 gives us the starting LBA for this partition. All right, so we just converted the CHS, hex 20, hex 21, 00. 00 there is the cylinder. We're the first cylinder, so it's cylinder 0, right? So that makes sense, I hope. So there you go. That should tell us. Let's go see if that's true. All right, so we're going to go back to FTK Imager, and we know that this is the CHS address, and it tells us that it's, we figured it out. It's 2048 is the starting sector. Let's go to partition number 1 up here and see where it is. Well, here's the beginning of partition number 1. Okay, there's a volume boot record here. You notice there's no master partition table down there because this is a volume boot record. But where is it? Well, let's look at FTK Imager. It's at 2048. How about that? That's the starting. If you don't believe FTK Imager, we can go to the beginning of the drive and go to the physical drive 0. So now we're at logical sector 0. If we highlight up here physical drive 0, now in the hex editor, we're looking at logical drive 0, right? So we can click in here and we can say go to sector. Well, we want to go to sector 2048. Go. Bam. Oh, there it is. We just went down. And there is the volume boot record for that partition. Or again, we know it's a volume boot record. There's the here's the NTFS header. Here's the volume boot record file footer or signature, and there it is. All right, so we're figuring this out. We are dissecting the master partition table, and we just did converting the CHS to LBA. All right, good. Let's look at the next byte over. If I recall, that's the 5th byte, so it's 0, offset 0, 1, 2, 3, 4, so hex 04 or offset 04 or the 5th byte gives us this 07 right there. There's a code there, 07. And you just have to know that there are tables out there. There are people smarter than me who have done a lot of research, reverse engineering this stuff. I don't know that Microsoft ever gave out this information. Maybe they did, or probably it was just some forensic examiners with paid to do some reverse engineering. They went in and figured out what does this become? Whoops. That's not what I wanted to do. What does this 04 byte become under with different file systems? And they noticed that if they've got a FAT16 file system, this says 04. If it's a DOS extended partition, it gives it a value of 05, and so on and so forth. We have a 07 value there, so we know that we have an NTFS file system. Okay, this may be important to you because you may be looking at a drive, and an FTK image or any sophisticated forensic suite's going to notice this right away. But if it had a value of 17 here, it would still be NTFS, but we would know that the owner of the computer went through some trouble to make this a hidden partition. And we know that because when the value here, when the left-hand column of the byte is a 1, that's indicative of it being a hidden partition. Okay, so those are the codes for hidden partitions. A hidden Linux partition, that's not true. That is incorrect information on this slide. Disregard this hex 83. That's just a standard Linux partition. That's a typo on my part. I don't know what the schema is for a hidden Linux partition. So anyway, there's your partition type header codes and a chart, and now we know what it looks like. Again, if sorry to be too redundant here, but if we go back to our master partition table here, we're looking at our master partition table right there. 07 tells us that it's NTFS formatted. We also see here that this one is 07. So my next partition is 07. And then the third partition down has a value of 27. What the heck is that? Well, it looks to me like it's NTFS. Not sure what the 2 indicates, right? So we need to do some investigating and find out why that's a 27. We notice that it is that this is a no-name NTFS. It looks like it's a backup. It really looks like it's just a backup drive. So maybe that hex 27 is probably a flag for a backup partition, backup NTFS, something like that. So we'd have to do a little investigating because I don't remember off the top of my head what 27 is. So we'd have to look into that. All right. Now back to our lecture here. All right, next screen, the LBA starting address in Little Endian. And if you don't know what Little Endian is, I'll do my best to explain that right now. But let's see, these next 4 bytes are the starting logical block address for the first partition. It does tell us that it's 2048. Okay, if we look at the hex value interpreter in FTK Imager. You could also figure that out by going to your Windows calculator, putting it into programmer mode, and then in hex value, with hex highlighted, you could type in the value 0000, which you wouldn't have to type in because those are zeros, and then 08, or you could just type in 8 because anything preceding it is a 0. So 800 is the hex value represented here in Little Endian, because Little Endian basically means we're going to read it backwards. We're going to read it right to left instead of left to right. This is the least significant byte, right? This is not as important as this. This is the highest value byte, and so the computer reads it from left to right, going this is the highest value, this is the smallest value. But when we do it, when we convert it in the calculator, we have to go right to left. Okay, so we're going to put in excuse me, the smallest byte first, going up to the largest byte, and there's our Little Endian value. When we put it in there, hex 800 is 2048. Okay, so what does that mean? Well, it means exactly what it meant just a few minutes ago, that the starting location, here's my master partition table, I'm going to go in here's those three values are the final CHS sector, and then these 4 bytes here is the starting LBA. There it is, 8000, and that just means, see if I've got that highlighted in little endian. If I go to my hex value interpreter, it tells me right there that the value of 800 is 2048. What is that again? That's the starting sector of this partition, which we already confirmed. If we go here to the first partition, then that tells us that we are on sector 2048. Okay, so that makes sense. It's all good. That's good. So that is our boot partition, essentially is what that is. File system reserved. That's the boot partition. Okay, and that's all good. So when Windows goes looking for the information to boot up, it's pointed to this first partition. So that's why this is our primary boot partition. Okay, so there's that. And again, we've already confirmed that. Now we just need to go down here one more time. Let's see what these last 4 bytes are. Last 4 bytes, the total sectors in little endian. So again, if we were to highlight this block and look at it in FTK image or go to the hex value interpreter, it would tell us that there's just over a gig. No, a megabyte. No, those are sectors. Total sectors. So a million sectors. If we wanted to confirm that using the Windows calculator, again in programmer mode, we put it in backwards, 0F. Now, you don't read it nibble by nibble backwards, and you know this is, so for example, 0F is a byte, 0 is a nibble, and F is a nibble. I'm sure you guys have heard that before. You don't read the nibbles backwards. You don't read this as F0. It's still 0F. So the byte, the value is 0F. Oh, byte 0F. This next one is A0, and this next one is 00. But so when you read in little endian, when you read from right to left, you take the whole byte. You don't read it the right nibble then the left nibble. You read left nibble, right nibble. I'm not saying nipple, by the way. That's awkward and probably a violation of some HR policy. And so we will read it right to left, but keeping the bytes intact. Okay, and so again, if you were to put in 0F, you don't have to put in the 0 because it's value of 0. If this was a value other than 0, we'd put it in. So 0F A000 or FA00. Convert that to decimal. It's 1,024,000. All right, so that tells us the total sectors in little endian for LBA addressing. Okay, so what does that mean? Sectors, well, that's just what it means. Let's go to access data here. Let's go to our FTK. We know that this partition is 500 megabytes. Interesting. We would expect that to be, again, well, let's go up here. Go to our master partition table and go to those last 4 bytes. And there's our value in the hex interpreter. Okay, I'm not going to do it in the calculator. But we would expect that to be, so what we will do in the calculator is we'll say, well, if we've got 1,024,000 sectors and we've got 512 bytes per sector, then that gives us 524 million bytes, or 524 megabytes, a little more. And now we can see that this partition is a 500 megabyte partition. So that's where they get that value, 500 megabytes, actually 524 megabytes, right? 524 megabytes, but it rounds. Okay, so that is, in a nutshell, how to decode the master partition table of a Windows MBR, and and that should help you with the assignment. If you have any questions, as always, text me or email me. But if you email me, be sure to text me and tell me that you have emailed me. All right, guys, good luck. Talk soon.